Hello guys, so today we are here to solve this swapping nodes in a linked list. This is a very interesting problem and it has been categorized into medium, but uh, to me, when I first looked at it, it, it looked an easy problem. And why it is an easy problem? Because, let's first discuss the problem, but let's discuss the problem description and then we'll go into the easiness of this problem. So in this problem, we are given the head of a linked list and an integer k. So let's say the head of the linked list is here, and this is the whole of the linked list. And we are also given an integer k. Okay. So in this case, let's say this is the linked list that we have been given. So 1, 2, 3, 4, 5 is the linked list. It is given like this. And then the integer k's value is 2. So what the problem expects us to do is that, take the second element from the start and that take the second element from the end and then swap them together. So I don't think we need to swap, we just should, change the values and that's it. But the thing is, the major thing in this problem is that we should be, mm, we should be, mm, we should be first be able to get hold of that node which is supposed to be swapped. So how to go to the node which can be swapped? And also, if you see the constraints of this problem, that the number of nodes in the list is n. N is, and it's also mentioned that k is always less than equal to n. Okay, k is always less than equal to n, and n is less than 10 to the power 5. So the main thing is that k is in between 1 to n. Okay, it cannot be greater than n. So the thing is that, k is always less than n. So this k can be, it will be less than the length of the linked list. So with this, we will start with the problem. Okay. So with this, we will start with the problem. And in this problem, we will solve this. Okay. So how to solve this? So since we have to count, k, it's better that we initialize one step variable which is equal to 1. And so our step, we will be given the head, pointer to the head, and we want to go to the second element. So head and then the next element. So within one hop, we'll be reaching the second element. So the number of hops is minus, one hop takes us to the second element, two hops takes to the third element. So with the, uh, if we increment, so if we can take it as 0 also, and then we can, take while step is less than k, okay, like this. And also it's better to, take the list node current is equal to head. Yeah. And one more list node, which is equal to, so this will be the first point, which will be equal to the head. Okay. And since k is, since k is, so this we can discuss later on. So since step is less than say, so we'll do current is equal to current dot next. Current dot next. Okay, so we're moving ahead. Okay. And once we get to a node, okay, so I think we should do like this. Yes, list node first is equal to current. Okay, so this will give us the first point, from the beginning. Okay. And now we'll start one list node second is equal to head, and while current so current when we are reaching this should be reaching this x is not equal to null, then we should not be going ahead of this. So our current, and now we see basically we are using this two pointer approach. So in this two pointer approach, we'll be maintaining two pointers. The first one is we have figured out that how it should be working. And then we'll be, as soon as the current is at this position, we'll be taking one, second at this position. Now current will come to this position, second will come to this position. Current will come to this position, second will come to this position. Current will come to this position, second will come to this position. Then this is null. Then we'll, at this point, we'll not move ahead. We'll just be stopping over there. So we'll say current dot next is not equal to null. Okay. Current is equal to current dot next. Okay. And then if current dot next is not equal to null, we'll be, moving second is equal to second dot next. And then at the end, what we will do, that we will do int temp is equal to first dot val is equal to second dot val is equal to temp. Okay. And after this, we are just going to return the head. Okay. So we'll run this code. So we are getting a null pointer exception because cannot, yes, we have to increment the step also. Okay. So we will run the code. Okay, so it's giving us the wrong answer. It's giving us the wrong answer. Okay. So it's not swapping the 1, 3, 2, 4, 5. Okay. So output is this. It's swapping 2 and 3. It should be swapping. Okay. So, okay. Okay. Solution of nodes is not equal to null. Okay. Okay. So now we are getting 2, 3, 4, 5. Okay. So see, we'll go through this problem. Okay. Current is equal to head. Okay. And step is less than K. Okay. So 2. Okay. Step is 0. We come here 1 and then we at this point. Okay. So current will move to this position. That is not that we want. Okay. So we should rather be, starting this with one value, that makes it much better, one and then two. Okay. If it is 0, then we should be moving till k minus 1. Okay, so if you are moving till k minus 1, why we are doing k minus 1? Because see, to reach to the second element, we need to take 1 half. Okay, now if we do, then what is the situation? So now it's accepting. Okay, so um, okay, and now we should be, doing some more tests on this. So we have done this. We will take this test case and take the fifth. So 1 and 5 should be swapped. Okay, so in this case, what's happening? Yeah, and elements are getting swapped. Okay. Uh, 0. Okay, k have to have value more than 1. Okay, that's okay. So let's say k is having value 4. Then 4 and 2 has to be swapped. 4 and 2 is been swapped. So I think this solution will work. Perfect. So this solution has been, found to be working, and it worked in all cases. But there are better solutions. So let's take a look at the even better solution. So this is my code. Let's go into the even better solution. Temp. Okay. So when count is equal to, here we started count value with 1. Our temp is equal to next. Okay. Acha, again he has done like that only. I don't think he should have used two rtemp. Where at all he is using rtemp? Uh, okay, so this one is needed. Okay, okay, yeah, 3 pointers are needed in this. Actually, 3 pointers are needed. Okay, yes. So we can do this, but I think my solution mimics this one only. If I go back to my solution, then yeah, So this is the way I have, done this. So let me know if you have any doubts, put it in the comments, and I'll definitely answer those doubts. Thanks a lot.